Hi, everyone. My name is Doris, and today I'll be talking to you about how the modern analytic workflows and pipelines are developed and the work that we're doing at our company Ponder to help make this more scalable. And just a brief background to myself, I recently finished my PhD at Berkeley, where I worked on building data science tools that makes it easier for people to visualize and explore their data. And in particular, I applied a lot of human-centered approach in designing data science tools and systems. And I'm now continuing some of this work as part of a company called Ponder, where we're building easy-to-use enterprise-ready tools that lets you work with data at scale. Now, we're at OSA Con today. There's been a lot of talks about the latest and greatest technology on leveraging open source tools, open source analytics to get business insights, to get data-driven insights. And so I wanted to take a step back and really take a look at how is data analytics being done today. And in particular, there are many different building blocks, workflows, tasks that often needs to be done in this modern analytics process, going from data loading, data preparation, exploratory analysis, and model development and training. All of this is part of the way that we find insights, explore our data, understand our data. And in particular, when what we know is that a lot of data scientists, a lot of data practitioners spends a majority of their time on kind of these earlier stages in the data science workflow, from data loading, from data preparation, feature engineering, and so on. And maybe even generating some visualizations and reports. And all of this requires a ton of work. This process is highly iterative. And in fact, in a recent industry report by Anaconda, it's actually shown that data scientists spend more than 70% of their time on these earlier parts of the analytics process, from data loading, data preparation, and so on. And so given that these early stages in the modern analytic process is so important, the focus of my talk today will be around, we'll talk about what are the tools that we use to do this today. And the secret here is Pandas. But unfortunately, I won't be talking about these cute, fluffy pandas today, but I'll be talking about the Pandas DataFrame library. So for those of you who aren't familiar with Pandas, Pandas is a tremendously popular Python library that lets you work with data frames for everything from data manipulation, data transformation, analysis, and so on. And this is typically done through the Pandas code, similar to what we see here on the left-hand side here. So we see that, in this snippet of code, we're importing the Pandas library, we're reading in some CSV files, we're doing a group by and average on a particular column. And Pandas is the library, it's the language that allows you to work with data frames. You could think of data frames simply as tables, but in addition to that, it also comes with these convenient functionalities and APIs that helps you load, clean, transform, and analyze your data. And Pandas is often used hand in hand in any of your favorite tools for machine learning and development. And so it's especially useful for things like feature engineering and data cleaning, where you often need to explore different operations and different parts of your workflow in order to get to the right pipelines. And so I talked a little bit about Pandas, but to really understand why Pandas is so awesome, first, Pandas is an open source project. It's been around since 2008 and has a fast growing community of users. It comes with a really intuitive API that makes it easy to learn and adopt. And we saw one example of that earlier. The other thing about Pandas is that it's so accessible, it's so easy to learn, that it's being taught in almost all introductory data science courses, Python boot camps, and curriculum that is out there. And in fact, it's often one of the first things that you learn when you learn how to use Python, the programming language. And so with that, we talked a little bit about the API, but it's really powerful in the sense that it's very flexible. It's great for ad hoc analysis and quick prototyping, and it allows you to very quickly get quick feedback, interact with your data. And so it shouldn't be too surprising that to date, Pandas has more than 2 billion total downloads, with an estimated number of more than 10 million users and a very fast growing community behind it. In fact, it's the #1 most popular data science library for Pandas. And it's pretty much used across all sectors, all industries, from finance, biotech, manufacturing, anywhere where you have to work with your data, Pandas is part of the data scientist toolbox. And so as we embarked on this journey in building out our company, Ponder, we started to talk to data science teams, industry data science teams, Pandas users in the wild. And what was clear was that many organizations are using Pandas for this initial prototyping exploration as new business requirements come in. Data science teams love it because of all the reasons we talked about earlier. But most of these prototyping is happening on a laptop or a single shared machine, where data teams can very quickly test out and experiment in an agile way. However, the trouble is that the moment you need to look at more data, maybe this is because you're testing or productionizing on a larger sample of your data, this picture starts to break down. So the tool that you're using for this initial stage, Pandas, doesn't scale. And so the reason why this is the case is that Pandas is single-threaded. So things can get really slow when you're operating on large data sets. And what's worse is that you can often only work on data that fits in your memory. The moment you exceed that, you start running into these out-of-memory issues, and it becomes very hard to hand-tune and optimize for these queries. And so to work around the limitations of Pandas, what often happens in a lot of the data teams that we've spoken to was that they're forced to rewrite their Pandas workflows, their pipelines, into a different big data frameworks, such as Spark or SQL, when they move these workloads either to the cloud or when they're running on a larger data set. And so when we go from prototyping to production, this now becomes a very time-consuming process of constantly having to rewrite these workflows into a more scalable framework. And so in a recent example from a team that we've been working with, this is actually one of the largest marketing firms in the US. They've actually told us that it took them over 6 months to translate one of their Pandas workloads into Spark, just to be able to work with more data in production. So this is the pipeline is doing the exact same thing, but just rewritten into a different language, into a different framework. And so this is an incredibly frustrating process and a waste of precious developer time. And the story doesn't end here, right? So even when you've gotten to the point where you've rewritten your workload in a more scalable ways, things can break in production, models often needs to be tweaked, bugs can get introduced. And so the rewrite process is not just a one-time cost, but kind of this constant overhead that makes it very difficult to maintain and debug your workflows. And so what I hope you take away from this is that all of these different points of friction of having to rewrite your code just to be able to work with more data starts to stack up in terms of human time, in terms of development cost, and it becomes a very real challenge. And so as part of Ponder, to address the issue of scalability, we've been developing an open source project called Modin. And you can really think of Modin as a faster and more scalable version of Pandas. So with Modin, all you have to do is change a single line of import statement, and all of a sudden you're getting much better performance, and you're able to work on much larger data sets. And so if we look at that same snippet of code that I showed earlier, your read CSV is now faster, your group by, your mean, and so on. All of these operations are much faster because Modin is able to Modin is able to run these operations in parallel. And so you no longer have to be an expert in distributed computing or to rewrite into a new framework in order to leverage scale in these cases. And you can focus on iterating quickly on your data. And so to date, Modin has been adopted by many industry data teams spanning pharmaceutical companies, tech companies, and even manufacturing companies. And it's used by more than 10% of Fortune 100 companies. It has over 4 million downloads and over 8,000 GitHub stars. And we were able to achieve this level of scalability for Pandas, really building on the fundamental research that we did in our research at UC Berkeley on adapting databases and distributed computing techniques to Pandas. And so we talked a bit about how Modin solves this scalability challenge by allowing data teams to seamlessly transition from prototyping to production while preserving this consistent API throughout the entire lifetime of the project. And so as a quick demo of Modin in action, and this is essentially, I'm a data scientist. I'm trying to develop this traffic prediction algorithm. So here I'm loading in a 2 GB data set, which is a New York taxi data set on my laptop. And here I have a side-by-side comparison of Modin and Pandas. And you can see that the only difference across these two notebooks in terms of the code is actually only the first line, for the first cell in the notebook, which is instead of importing Pandas, I'm importing modin.pandas. All the other queries is staying the same. And so now I'm going to start running these two workflows and see which one completes first. So we can see that Modin has already completed running while Pandas takes much longer. And in fact, when you actually look at the performance of each of the operations, here we're doing read CSV, is null, which is checking if the data frame contains null values, and then an apply map, which essentially applies an operation across the data frame. You could see that for every single operation, we can see significant speedups with respect to Pandas. And so what's the magic here? Like, why is Modin able to run much faster? So as we explained earlier, Pandas is single-threaded, which means that if you had more cores in your machine, you're not really leveraging these resources. It's not able to fully utilize the resources that is available to you either on the cloud or in your own machine. And in contrast, Modin allows you to run these data frame operations in parallel. And it does so by partitioning the data sets automatically for you and distributing the work into each of your each of the resources that you have available, so that we can now fully utilize the compute resources to speed up our performance. And so even beyond that, in fact, the more cores you throw at it, the better it does. So especially on very large data sets that can't even be processed by Pandas, Modin can work even in a cluster setting. So in some of our research paper, we've actually ran benchmarks comparing Modin with respect to Pandas and other parallel implementations. And Modin's performance always comes out ahead, leading to orders of magnitude speedups across a variety of Pandas operations. So as part of Ponder, we've been working very closely with many of our customers to help them put Modin into production, from finance, from e-commerce, AI and ML companies, and many other Fortune 100 companies and leading data science teams. One of the case studies, one of our customers is actually a very large financial institutions. And they came to us with a very large regulatory reporting pipeline. This was all written in Pandas. And there were various components of this pipeline. But what it essentially was doing was it was reading to and from a data warehouse, extracting, loading, and transforming the data in various ways. But the challenge here was that the slowness of this existing Pandas pipeline limited how much the team can actually iterate on their forecasting models. And so so when we started talking to this team, they wanted to use Modin to parallelize their existing Pandas workflows to let them run on data at much larger scale in a shorter amount of time. And so because they were operating on time series data, they often had to sample down their data. And previously, they were only able to look at 6 months worth of data. And with Modin, with the single line of change with Modin, they're now able to process more than 60 months worth of data. What's actually more interesting for the team throughout our working collaboration was that they were also able to dramatically simplify their code base, because Modin automatically figures out how you can parallelize your Pandas workflows without actually needing to change your code. So we were able to remove a lot of the, a lot of the code that was specialized for making the data scale manually. We were able to remove a lot of that for our customer. And so as a side benefit of using Modin, the code base actually became much more maintainable, much more accessible to other members of their team, which is a huge plus for their production use cases. And so to recap, today in the talk, we talked about the modern analytics process and how Pandas is used for many crucial analytics tasks, such as data preparation, exploratory data analysis, feature engineering, and so on. And everyone loves using Pandas because of its flexibility, its ease of use, and convenience. But there are also really challenging pain points around how to make Pandas scale on large data sets, which is a super common use case in many enterprises. And we talked about how our open source tool Modin solves the scalability issues that we've seen around scaling Pandas workflows without requiring the users to change a single line of their code. And so finally, if this is interesting to you, if you're using Pandas in your everyday work, we're actively looking for folks who can try out and provide feedback on our product. So if you'd like to learn more about what we're building as part of Ponder, feel free to check out what we're building at ponder.io/product, and you can sign up to try out our tool. And so with that, I'm happy to take any questions with the remaining time.
Doris, this is Robert Hodges. You have a question in the Q&A box.
I'm going to read it for.
Oh, sorry. Yeah,
That's okay.
I didn't know if you saw it.
So Kanthi wanted to know, can Modify run natively on Kubernetes without Dask or Ray? Modin, sorry.
Yeah, so Modin currently relies on two different. So we support two different backends, Dask and Ray, and Modin can actually run in a single node setting. So all of that, like the spinning up a Dask cluster, spinning up a Ray cluster is already done for you in the single node setting. In the cluster use cases, people often use various different orchestration solutions to set up a Ray and Dask cluster. And so in those larger cases, you would need to leverage Dask Array. But yeah, those are the two compute engine that we currently support.
I have a question. This is Robert. So there's a koalas implementation at Databricks. How would you compare that with what you've done in Modin?
Yeah,
that's
a really great question. So Databricks has this like DataFrame API. I could actually pull up this slide, which actually talks about like one of the best parts of Pandas is that the API is so flexible. It has something like more than 600 or so APIs. And so Modin really stays true to the idea that, hey, we don't want the data scientists to change any line of their code, to have to rewrite their code into a different set of API. So when you actually look at the API coverage of pandas.dataframe, which is the native Pandas API, koalas and the Spark DataFrame only supports less than 60% of the Pandas API, whereas Modin supports more than 90%, which really allows Modin users to use the Pandas API without a lot of changes to their existing workflows. So it's really around that coverage compared to our other existing solutions that are out there.
Thank you. And this project was originally something that came out of the RISE lab at Berkeley, or?
Yeah, this is a project that me and my colleagues, Devin Peterson and Aditya Parameshwaran and many others, was working on at UC Berkeley. So the project has been ongoing for 4 years now, and so we've been working on this prior to starting Ponder.
Great, thank you.
Kanthi has a follow-up. Is Modin supported in AWS platforms like EMR or Glue?
Yeah, that's a great question. In fact, in our documentation page, I believe that there's an example of how you can run, you can set up Modin on AWS, and there's a quick start example if you want to set up a cluster there. So I highly encourage you to check that out.
Any other questions for Doris? Get them in. We've got plenty of time. Well, Doris, it seems you've given us a very informative talk today. Thank you so much.
Thank you so much.
Thank you very much.
We really appreciate you being here with us today.
Yeah, this is a very exciting event.